Oh, I do see it. All right, got it.
Streamlines it. Hello, everybody. Welcome in. Come on in. I was saying earlier, it's been so long since we've done a webinar because we've been doing so many meetings where I can see all of you. So I'll have a look and see if I recognize some names. Oh, great. Yeah, great. Hey, Bob. Hey, Andrew. Hey, Charles. Hey, Corey. Nice chatting earlier. Lots of lots of familiar names. I will admit I prefer the meetings. I love when I could see when you can see everybody.
Yeah.
But, hey, Paige. Cool. This is great. Hey, Wink. Struan. Awesome. We'll just let everybody filter in. And then we're very excited. This is going to be a fantastic presentation. I'll do a proper introduction once everybody's filtered in. I was saying to Anne, we overbooked this one, but as we all know, a large percentage of people don't show up. So hopefully, fingers crossed, everyone gets in. Hey, Corey's in the chat. So if you're new here, we do these every month. We do the interactive meetings for members every month, and we do one of these publicly every month. And we're going to do questions and answers at the end. We're going to let Anne blow our minds. And you can go ahead, as you can see in the chat, we've already got Anne and Corey started in the chat. While Anne is speaking, I'm going to be moderating the chat just in case there are any technical issues. And then if you have questions, you can look at the bottom of your screen and there's a Q&A. So if you click on the Q&A, you can submit your questions there and then we'll come back so that we don't throw off Anne's flow. So we'll just go ahead and give this, and let's give it one more minute if that's okay, because I still see people coming in. And in the meantime, I'm gonna introduce Anne. I've known about Anne for a long time. Anne, you've been around. I don't know how to say this without it sounding bad, but you've been around for a really long time. As an angler, I mean, obviously, you're you're an author, you're an aquatic biologist, but you're also a longtime angler. And I think that's a really important point to make because it's one thing to speak about bugs in entomology, but it's another to know how to fish them. And I think that's why you're so unique. And I know it's why I'm really excited to hear more about you. So Anne has got an upcoming book. She's got a book on her way. We'll talk about that more later. Where can people, and we'll dive into this later, but where can people buy your current book? Because you do have a book out right now.
It's absolutely unavailable. There have been, I've seen it on Amazon for like $890.
Right.
Don't go out and buy that. Right now it's up there for $200, and I consider it a great compliment that no one's selling. So that's great. But it's I have, you know, I'm clinging to a couple copies personally, but I will be republishing later this year, and I'm adding a new chapter on terrestrial insects. So it'll have a different cover. So I will, if you're interested in that, maybe, I'm not sure how we do that on a webinar, but April, if you can keep track of emails and get them to me, then I will. I've been amassing those, and then we'll let people know when it comes out.
Sure, yeah. And if you're comfortable sharing your email at the end, you're more than welcome.
Or you know what, I'll put it in there right now, and
Great.
people can actually directly email me, and that makes it easier for everyone.
Perfect.
Good.
Excellent. All right, well, let's rock and roll. And if you want to share your screen, we'll get started.
All right, here we go. Share screen. All right, I got to put in some kind of password, sorry.
Okay, that's all right. There we go.
Y'all see that?
Yeah.
Okay, great. So thank you, April, for inviting me this evening. And I'm very passionate about sharing information, and I'm hoping that I can do that this evening and maybe teach you some things that you don't know, or explain some things you're maybe curious about and don't quite understand. So when we're little, I think we all have a real fondness for insects and certainly play with them and interact with them until something happens, maybe we get bit or stung, and then suddenly insects aren't such a great thing anymore. And we, as you kind of run away from them and swat and kill them until you get into fly fishing. And then all of a sudden, insects are where it's at. And we want to know everything there is to know about them. And I became involved with different groups over the years and teaching introductory fly fishing. And because I was the aquatic biologist, I always taught the entomology section, which was, really fun for me. But I became really frustrated because there was no good reference that would showcase not only the insect, but also the flies then to imitate that. And I know when I got into fly fishing, I would hear 6 different names of a fly that would imitate an insect, and I would go back and forth and back and forth, and it was really, really frustrating when I first began. I think that it probably is still very frustrating to people when they get into fly fishing. So, long story short, instead of copying, pasting handouts for people, I decided that I was just going to write that book. And so I started. It probably was back in 2008 or so. I decided I got a contract with the motto to write a book, and I had 3 years to make that happen, which sounds like a little bit of a long time, but it was kind of like a giant hourglass, and I turned it over, and the clock started. Starting off, collecting the immature stage of the insect was relatively easy. I had to, find them in all of the various rivers. They're fairly cooperative when you go to photograph them, but the adult stage was a whole nother story. And oftentimes I would get home, I'd go to the river, I'd bring these insects back, and the insect would be half dead, or maybe the wings would be broken. Uh, Sometimes I would have to put them in the freezer and try to slow them down. And then when I would get them out, I would have gone too far. And lo and behold, you can't revive something that's been completely frozen. So, as artfully as I posed these and thought, well, maybe I could Photoshop a tail onto this, the reality is that's not going to work. So, 6 months into the project, I really had a panic moment, and I thought, I don't know how I'm going to do this project. And I remembered a colleague in grad school who had created, I was studying algae at the time, and he had developed some artificial streams and was raising algae. And I thought, well, maybe I could do that with insects. And this was a rather rudimentary um, river to say, or stream to say the least. But what you see here are a few eaves troughs on angles with a recirculating pump. And in those eaves troughs, I have all kinds of river material. And then I've got river water in there, and I have a recirculating pump, and that water is flowing constantly. So I have a little river in there. I also had frozen milk jugs to keep it all at a certain temperature, and I had also oxygen coming in from the bottom. And I would inoculate these little streams with nymphs, 2 or 3 different species at a time. And then lo and behold, it worked really well. I wasn't raising these from eggs, but actually insects that were 1 or 2 molts away from becoming adults. So it turned out to be actually very successful, very laborious, I might add, but I got perfect adults every time. So I could actually reach into that netting and extract the insect and then take it into my photo studio in the basement of my home, and then take the photos. I didn't have any broken tails that way. I didn't have any broken wings, and it worked really well. So we gave up using the garage for a few years. I had at any one time, I think I had up to 4 of these streams running, maybe more. And then I had all these tanks with the various immature stages of the insect ready to put into each one of these different streams. So the end result was Hatch Guide for Upper Midwest Streams. And this came out at the very end of 2011. And it is now, no fault of my own, it's out of print. And I am going to republish it independently. And I hope to have that done by the end of this year. I was hoping midsummer, but that is definitely pushing it. So hopefully, probably by fall, mid-fall or so. So you've got my email there. And if you send me an email and say, I'm interested in this when it comes out, I have a list of people to get in touch with. So that's a little bit on the background of how I wrote this book. Now I want to kind of integrate the whys and how to hopefully take some of this information and make yourself a better angler. And as April said, I've fished for a really long time, fly fish for a really long time, and I've gone through a lot of the ups and downs and hardships and trying to figure things out. And once we get all of our gear and equipment, we're pretty much set on that. But, the fly thing is something that constantly changes depending on where you go, what season, and so forth. And so often we get to the river and we just sit there and it's like, oh, geez, I don't know what to put on. And, 2 weeks ago I used this and it's not working now. I used it on a lower section of the river and it worked great, but it doesn't work here. And why is that? And really that's kind of the $100 question of fly fishing. Why do you choose a fly when you choose it? And how can you do it differently to become more successful? So as you look at different sections of this, I'm going to show a few slides with different water. Here you have kind of a cascading stream. You can see some elevation changes. Here's a big pool, certainly deeper. You can imagine that the current might be slower. The light penetration is different than what the previous slide showed. Here's a nice riffly section, probably a swifter current, more oxygen in that water. Here's a section of the river that's all gravel. And you might think, oh, what could live there? But actually, there's lots of insects that live there. In fact, if you look closely, you can see all these little caddis, little case caddis living on all those little bits of gravel there. And finally, in lots of streams here in the Midwest, we have woodland streams with lots of downed wood, decaying leaves, sections of gravel and sand. And so my question is, when you think about a hatch guide and you look at it and you think, oh, when I go to the river, it says all these bugs are here. But in fact, each of these different places have different insects living in it. And so let's look at some of the reasons why that might be so. What are the different reasons that, what variables determine insect hatches? So first of all, I'm sure we have some people there in the Western states, also the Midwest. I know there's some people, some Eastern states as well. And as you travel around the country, you will encounter different hatches wherever you go. And as you learn more about hatches, you'll find that depending on different families and different genera, they'll behave very similarly. They might have a different name, but if you learn them in one area, they'll act and behave and be very similar in another region. So each of the various regions in in our country are going to have some unique hatches and some overlapping ones as well. So another variable that determines insect hatches is phenology, which is a very fancy word that essentially just means the natural order of things. And so I like to make this analogy to flowers blooming in your garden. And the first to bloom are crocuses, and then comes daffodils, then tulips, then iris, then lilies. And every year they bloom in exactly the same order. If it's a very mild winter, those crocuses might bloom, much sooner. If it's very harsh, they'll come along later. And the same is true with insect hatches. They hatch in exactly the same order every year. And so as fly anglers, that really works to our benefit because we can go to a region and say, oh, it's May. I can expect, X, Y, and Z to be hatching. So I can be prepared with flies when I get there. Habitat, and I kind of alluded to this in those previous river slides. Habitat is something that I think anglers really overlook. And I really like to stress this when I talk to different clubs. When you think about like if you're a bird watcher and you were looking for warblers, especially this time of year, you're probably not going to go out to a pond to look for warblers. You're going to go to the woods. And by the same token, if you're looking for ducks, very obviously you're going to go to a pond, not into the woods. And the same is true with insects. They're very, very particular about where they live based on what they eat, the current requirements that they might have, maybe temperature as well. And so all insects have a particular habitat that they prefer. And so in any one of these environs that we look at, there might only be, a handful of hatches in each of those, more than a handful, but certainly not all the insects in a hatch guide in one region. And then lastly, the time of day is important in determining hatches. Early in the year, we know that hatches happen midday. And then as the season progresses, they move maybe to mid-morning, later afternoon, and by the time it's summer, they might be hatching extremely early in the morning and late at night. So a few different variables that help determine insect hatches. So let's do a little science here. So when we go to school, everybody learns one life cycle, one insect life cycle, and that's the monarch butterfly. And we know that there's a caterpillar, and then it changes, it metamorphoses into, into a pupa stage, whether it spins a cocoon or a chrysalis. And then after a period of time, it hatches into a butterfly. So the immature stage and the adult stage look really different, and something in between, magic happens. So that's true with, certain insect orders, but there's a whole bunch of insect orders where there is no pupa stage. So think of things like grasshoppers and crickets. There's no pupal stage there. There's no big radical change. They just start off as an egg, and then they're a little grasshopper, and then a little bigger, a little bigger, a little bigger. And then in the last stage, they have wings. And so that's a gradual. So that's called that kind of a change, insect change, is called an incomplete metamorphosis, where you don't have a pupa stage. And mayflies are an example of this. So the female will lay her eggs, and she will lay, upwards of hundreds to thousands, depending on different species. And she'll lay those all at once, so they're all the same age. And then those eggs will grow and develop over the course of a year. And they'll grow and molt, and they molt, they have an exoskeleton. So they have to, as they get bigger, they have to molt, and they might molt, upwards in some of the species, 25, 30 times. And then all of those immature stages are going to be developed and ready to go all at once. We call that stage a nymph when there's an incomplete metamorphosis. So we have mayfly nymphs, and we'll learn some other things as we go on and talk about different orders. So after a year, those nymphs are all going to get ready. They're going to start staging and get ready to swim to the surface and become adults. Those emerging nymphs will swim to the surface, and they'll split right along the thorax region. And that last molt will have wings on it. The wing pads will be actually visible if you collect one of those last molts in the nymph stage. And then the dun will be ready to go and fly off to surrounding vegetation. And it'll rest there for a day or two. And all of this, when I say it, know that there's, of course, going to be some variation between species. But after a day or two, that dun is going to molt one more time. And during that molt, in that last molt, then the sexual organs, the reproductive organs will be fully developed, and they'll be ready to now reproduce. They're very, very short lived. They only live a few days as adults, so they don't have any mouth parts. And the males will come back to the river first, and they will gather together in what we call a spinner cloud. And it's just a big bunch of males, and they're flying around trying to attract females. They're emitting pheromones in hopes that the females will show up and that they will mate. And that's, of course, what we want as fly fishers. We want the females to show up. And if they do and they mate, then the females will come down and they will lay their eggs. And if you're a mayfly, that means great, because the life cycle has been completed. And if you're an angler, that means great, I might get to catch a fish out of all of this. So it just depends on your perspective. So what's pretty cool, though, as fly fishers, we can imitate all of these different stages with a fly. The egg-laying female, the emerging nymph, the emerger itself, and then the dun. We have patterns for all of these for all the different species. So a mayfly nymph is relatively easy to identify. It has 3 tails, and its gills are all located right there on the abdomen. The mayfly dun itself has 2 pair of wings. It can have 2 or 3 tails as an adult. And like I said, they have no mouth parts at all. They don't feed as adults. But in general, when you see a mayfly dun, as you get familiar with them, you recognize right away they're very dull in color. So duns are dull. And if you look closely at this slide, you can see some tiny little hairs on that wing. And the dun itself is actually covered with lots of tiny little hairs. We can't see them, but that is actually what causes the dun to be very dull in color. So not very bright. You can't see through the wings. But then when it molts into the spinner stage or the reproductive stage, the colors become much more intense, and you can see through the wings now. Now, some other things between males and females. Males in all of the mayflies, both duns and spinners, have really big eyes, and the colors are different in different species. And in some species, the color might look different in different lighting. So don't get worried about that now. But the males also, when they go from the dun to the spinner stage, have this, it's like their legs telescope out. And in the spinner stage, they're super long, and the tails become also very long. And they need to have those great big long forelegs to be able to reach up in the spinner cloud and grab the female and then mate with her. This is what it looks like when a nymph starts to emerge. You can see the old exoskeleton there to the left, and the tails are coming right out of there. And then boom, it's out and ready to go. This happens actually sometimes really quickly. It might be a matter of a few seconds. In some of the bigger mayflies, it might be upwards of a minute, maybe a little bit longer. This is what it looks like when a dun molts into the spinner stage. We don't usually pay attention to this. This happens away from the river, so we might not even see it happening. It can happen along surrounding vegetation, on the sides of buildings, on gas station pumps, and you'll find the little leftover shucks behind. And if everything works out and they successfully emerge from there, then the spinner is ready to return to the river and reproduce. So remember a few slides back, I talked about the way to differentiate a mayfly nymph was by 3 tails and the gills on the abdomen. And these are all mayfly nymphs, so they look really radically different, but they are indeed all mayfly nymphs, and they all have different body types that are really adapted for where they live. So they have very specific habitat, and these body types are adapted for a particular unique habitat. So, for example, the clinger type mayfly, they live on really big rocks and cobble. They can also live on woody debris, but if you try to pick them up, if you're out collecting it all, they can be really, really difficult to even remove from their substrate. They're that, sucked down and flattened. The crawlers, on the other hand, have kind of spindly legs. They crawl around in gravel for the most part, in the little interstices of gravel and cobble. Burrowers, you can almost see the hinge right there in the middle of that. And a burrower, actually, if you look at the head there, you can see it's got some tusks, and its front legs have little shovels on them, and they actually dig little burrows and live in there. They have very uh, feathery or plumose gills that help with their respiration in that kind of low oxygen environment, and they live there. And then the swimmers, they actually, if you catch them and put them in a little dish, when you see them swimming, they look just like a little minnow. So a lot of different body types, and for an assortment of mayflies. As you start to study this, you will learn, however, that each of these different little groups of mayflies, as an adult, there are things that we can learn about them. So for example, and this is another whole topic, I don't want to go too far down the rabbit hole here, but all of the clinger adult mayflies have mottled wings as adults, and they have 2 tails. So that's kind of cool. Everything in the crawler group as an adult have plain wings, and they have 3 tails as adults. Also, many in this group have male and female that have, 2 colors, kind of like with cardinals, where you have the red cardinal and the sort of drab female. Burrowers, not as neat and tidy. Some of the burrowers have 2 to 3 tails. Wings are, for the most part, marked there, or have, some modeling. And then in the swimmers, they all have 2 tails as an adult, not so neat and tidy with the wings. So kind of some nice little dichotomous key stuff going here, but I'll stop there. I won't get too detailed. So let's pick one of these groups and kind of look at all the variables that I talked about back at the beginning, and take that through. So crawler mayflies are going to live in a very gravelly type river, in that kind of substrate, and they crawl along in there. But they don't, sometimes as anglers, we think of nymphs just swimming up and down all over in the water column. And when I say water column, I mean from the bottom of the river to the water surface. And if the nymphs were swimming up and down in there all the time, they'd all be eaten, and we wouldn't have any mayfly nymphs. So we really don't have nymphs active and moving around except right before they're getting ready to emerge, or if there's a disturbance like, a flood or something episodic, or due to a phenomenon called drift. And drift is a natural phenomenon that happens, especially twice a day, at dawn and at dusk, and about an hour on window there, and then also from about mid right around 2 a.m. But we're not usually fishing then, so it's not as important. But if you fish a nymph, if you're up at those times, know that that's a high drift period, and certain insects really move around a lot. And scientists have spent an inordinate number of years studying drift and trying to figure out, why do insects do this. There are a lot of theories. um, a lot of it has to do with, if you're an insect and you've eaten everything in this small area, and you're out of food, you're going to have to move. And they do it especially at these two different times a day. It might also be because a predator has come in, and suddenly you're threatened, and it's time to move south. So in fishing, a beadhead type pattern for this crawler mayfly is going to be effective. They do swim a little bit. I have a little video to show you on that. So moving them up and down, and providing a little action to indicate uh, the natural is going to be more effective than just letting it swing and not move. Here's that mayfly that we were looking at, the crawler. This is the Hendrickson. I guess I didn't use the Latin name before, but Ephemerella subvaria, very common here in the eastern United States. I don't believe you don't have it in the West, but you have some other, I think in Ephemerella, in Ermis, and some other paler, your PMDs and your pale morning doves and your pale evening duns are in this same group. So males here, not the same colors, but just cousins. But with the Hendrickson, first of all, you can tell it's a male because it's got those great big eyes. But look at the body color. It's kind of a reddish color with plain dark wings. And then here is the female, the same plain wings, but her body color is kind of more of an olive brown. 3 tails as adults. And if you look at them in black and white, and a lot of our old hatch guides were all in black and white, which made it incredibly difficult to learn anything. But look at the profile of the bodies and the wings of the male, and there again with the female, and you can see, sure enough, it's the same insect. Now, so the question comes up, do you have to have a male Hendrickson and a female Hendrickson? And the answer to that, of course, is it depends. So in any insect group, especially with all of the aquatic insects that we talk about, but in other insect in general, the females are larger than the males. And so it's like, okay, that's great. So you'll see, say Hendrickson size 12 and 14. Well, a Hendrickson 12 is going to look, body color is going to be different, and it's going to be larger than that reddish male. It's like, okay, well, do I still need to have both of them? And the answer, the reason I said it depends, it's not because I'm being cheeky, but in an actual hatch, what will happen is the males will hatch first. So in any female's cohort of eggs, those thousands of eggs, the first ones that hatch out are going to be males, and that might happen for a couple of days, 2, 3 days before the females start hatching. So sometimes in a small little area, a fish might start feeding on the smaller mayfly. And when you come along with a female, it might not eat that right away. It might take a day or two before they become less selective. I'm not saying that trout are always that selective, but if you're in a situation where that's the case, then a lot of times certainly dropping the size of your tippet, but also dropping down a size in your fly um, will make you more successful. Here's the Hendrickson male, and of course it says male, so you know that, but you could also tell because, of course, the big giant eyes. But also, remember I said that the legs get really long, and look at how huge they are. I mean, it's almost ungainly as it's sitting here on this rock. And again, it needs to have those great big long legs in order to grab the females in the spinner cloud. And also the tails are really, really long. So whenever I think about fly tying, and we spend a lot of time making sure those tails are the same length as the body. And it's like, that's fine for a female, but if you're imitating a male spinner, just remember, they're pretty long. They're probably 2.5 times the size of the body itself. Here's the Hendrickson female. So she still has kind of that brownish body and clear wings. But many times when you see them on the river, you'll see they'll start to um, actually have that egg sac kind of halfway, almost all the way um, closed out of their abdomen as they're coming to the river and getting ready to drop that as an entire bomb, really, onto the river. Other mayflies have, they don't all have these egg balls like this, but in this group of insects, they do. And so what she's going to do is try to get her abdomen to the river and just get that egg ball off, and then she's done. She might be out of energy then. She might fall on the river and try to dislodge it that way. So a lot of times in patterns, tires will incorporate that egg color right into the pattern. Okay, so now here's a little very amateur video. And I want to say a little bit about this last stage of the nymph before it's ready to emerge. These insects, these nymphs, these mayfly nymphs, their mouth parts completely degenerate. Their alimentary canal completely shuts down, and you can actually tell if it's a male or female. You can see the eyes, the size of the eyes is on male and female, and you can sex them. It's pretty neat. So really this last molt, they're just getting ready to get up there. They've got big wing pads. And these are in my tank. So this is interesting. This little behavior it does with its tail is actually a defensive posture. And they've done studies where it will show that kind of scorpion action with the tail will actually deter a fish from eating it. So I have quite a few Hendrickson nymphs in this tank, and they're all starting to get active. And they'll start attempting to swim up to the surface. And a lot of times this will go on for a while. Most of them will be unsuccessful over a course of, a few days. Of course, this is in a tank, so I'm not sure I can say that's happening in the wild, but I'd like to. A lot of you know Kelly Gallup, and he wrote a whole book on stages of mayflies called stillborns and duns. This is an example of a stillborn, and it's sitting right up there at the water air interface, and it just can't break through. The thorax will not split open, and this poor insect, I watched it probably for 45 minutes, and it's continued to live, but it couldn't successfully emerge. So fish can really just pick on these, and they're just easy prey items, and a lot of them perish that way. So once in a while, everything works out. And you can see the winged adult there emerging, and the empty shuck falls down to the bottom. And then that insect is ready to take off and fly away. So that happens pretty fast. Here's a shot looking down from above in the tank. There's a dun that has hatched, and boom, here comes another one. And off she goes. I'll show you that again. You can see that the one that emerged was a male, and a female coming up below. So a couple takeaways from this. You really need to have, be prepared when you get to the river and know what flies you might need. Don't have every fly you own with you. Have your box stocked with, the few flies, the few patterns that are going to potentially be out there. And second of all, you need to be really adept at tying your knots. So if it's taking you 10 minutes to change out a rig, it's very possible that you're going to miss, most of the hatch, because a lot of these are going to, have come and gone by the time you get re-rigged. Okay, now watch to the left of your screen. There's a dun that's hatched, and along comes this poor little thing. Boom, it's gone. I've got a better picture here. This is a crippled mayfly, and it's still living, but you can see, in fact, there's one wing that almost made it there on the left side, but the rest of those little wings are still in their package, and they never made it out. And so sometimes we tie patterns that are what we call cripples. You can always make a cripple out of any pattern in your fly box by just cutting off half of the wings, and presenting it that way. And I have been in situations where fish were just stacked in a little whirlpool area, and emerging insects were coming down in there, and I tried emergers, I tried perfect little parachutes, until I presented a cripple, the fish would not eat it. And they sometimes just really fixate on these, because, face it, fish are lazy, and if you can just go up and eat that without much effort, why wouldn't you? So consider all of the things we talked about in the variable. Let's think about those different insect life cycle stages, and how we can figure out what the fish is feeding on. And the fish rise is really helpful in this. And if you're in a situation and you see a bulge where, something, you see a break in the water, but no body parts coming out, then it's feeding something completely underwater, either a nymph or an emerger, or even maybe one of those stillborn stages, but something underwater. If the body breaks the surface, the dorsal fin and tail, then it's feeding just slightly below the surface, eating an emerger. If you see a porpoising fish, it's very steady like that, head, dorsal, and tail break the surface, then you have an emerger or dun feeding. And then, of course, the simplest one to figure out, which I didn't show you any video of, is when you have just a little sip or a little nose coming out, and that's the spinner when the fish are eating spinner stages. So next, let's think of with that particular crawler hatch, let's think of those Hendricksons and apply all of the variables that I discussed in that first slide. Geographically, the Hendricksons in the eastern US, the time of day or the time of year, the phenology is end of April, early May, right? For us here in the Midwest, right around opening day. The sizes that you need are 12 and 14, the bigger size for the female and the smaller for the male. And the time of day, the duns will hatch in middle afternoon, sometimes into late afternoon, and the spinners will be in the early evening. Most importantly, though, is the habitat. You've got to go to a river that has a gravelly substrate in order to find any Hendricksons at all. So don't bother going to a tailwater or a silty type environment to try to fish for Hendricksons, or you won't have any success. Now you can do this little index card for virtually any hatch that you encounter, not just mayflies, but you know all of the other insects that we talk about this evening. And really, I guess that's the whole point of a hatch guide. You should have all of this information there in this, basically summarized for you. This is a nifty little device that I carry with me. I used to carry a little bit of netting, and when I was on the river, I would seine for insects and see what was in the film. And then somebody got smart, and instead of spending 50 cents for this netting, now I can spend probably $20 for this device. But it goes right around my net, and then a nice piece of elastic, and I can stick that in the film and see what's out there. Takes a few minutes and then folds right back in. Okay, so that's mayflies, and we could talk about all those other groups, the spinners, or excuse me, the swimmers and clingers and burrowers, and that's all really really fascinating. But I wanted to talk about all the other major orders, so we'll keep it more basic tonight. And so stoneflies, a very important group, need really cold, well oxygenated water. So we find lots of those in the West, and we have them in the Midwest and East as well. Again, an incomplete metamorphosis. So we call the immature stage a nymph. Most of them have a 1 year life cycle. So the female will lay her eggs, and they will grow and molt. You know, Not quite as many molts as the mayfly, but upwards of 20 or thereabouts. And when those are all ripe and fully developed, they don't swim to the surface, but they have to crawl out on a rock or vegetation or roots, something along the bank. They can't swim to the surface. So they will crawl out, and that's of course how they get their name, crawling out on stones. And they will, the thorax will split open, and the winged adult will come out. The Very often, as soon as those stone flies emerge on the rocks, they will mate immediately. Oftentimes, there's no fancy mating swarm with stoneflies. They mate, boom, as soon as they emerge, and then they fly off and rest on the vegetation. They could also, mate along the vegetation, but I've seen them mate immediately, as they emerge. Um, they do have mouth parts, and they do live for a while, maybe upwards of a week or two, depending on environmental conditions. And then the female is the only one that comes back to the river. So the males just perish. Um, never really returning to the river at all. And the female will come back and she will lay her eggs, and then the life cycle is full. So as anglers, we really only have a limited choice here in imitating them. The egg-laying female and the nymphs as they are developing. And stonefly nymph, it's pretty easy to identify. They have two long tails, two long antennae. Oftentimes, not always, but sometimes very kind of elaborate modelings on the nymphs themselves. They're kind of pretty. They also have two sets of wing pads that are rather pronounced. Sometimes stoneflies, when you turn them over, you'll see some gill tufts. Some have, little gill strands coming out of their chins, or out of the very rear of the abdomen. But many stoneflies don't have any gill tufts at all, and they really take all of their oxygen in right in through the cuticle itself, just oxygen diffusing from the river in. The stonefly adult is very flattened in appearance, has two sets of wings that are, nicely folded and laid right over the body. Sometimes some pretty colors in there. Two long antennae. Sometimes an adult will have tails. In some species, some genera, they don't have tails at all, or they're very reduced and unnoticeable. So this is what it looks like when a stonefly emerges. So they'll crawl out on a rock and they start to kind of wriggle out of there. Much lighter in color as they first emerge. You can see how the fluids start to pump into the wings and they unfurl. It's really, really pretty. Really bright colors as this is happening. And this is often, not always, but for many of our summer stoneflies, this happens under cover of darkness. And that's a good thing for the stonefly because it takes a long time. It takes about 45 minutes for that emergence. So you can imagine they must be very easy prey for, I think, of little mice and things crawling along on the rocks when these are emerging, and probably many of them are eaten because of course they're completely helpless. Even some of our winter stoneflies I've photographed, and they take they're smaller, but they might take upwards of, half an hour or so. Yeah, so in fishing, these two different stages, the nymph stage, you have to think, like a stonefly. I don't want to get on the bank and throw a stonefly nymph to the middle of the river before an emergence, because all the stoneflies are moving toward the bank to emerge. So really what I want to do is be in the middle of the river and fishing back to the bank and using, nice weighted nymph to get down and drift along and imitate those moving population of stoneflies. And you're probably wondering what that little white fly is there. And stoneflies and even mayflies, as remember I said, they have a lot of molts as they go from egg up to adult. And when they molt during one of those stages, whoops, that's not the place. Maybe I didn't put that slide in. I'll just tell you, the molted stonefly is completely white, and it might stay that way for like 12 hours, and they're very vulnerable to fish at that time. And I saw a lot of these when I was raising them. I'm guessing that in the wild, they're probably careful to stay tucked away under the rocks, but in the event that they do get exposed, they're pretty vulnerable to fish. Here's an egg-laying female, and you can see how her eggs look, kind of like more like a blackberry almost. And as she goes back to the river and is laying her eggs, she's dipping her abdomen in and out, trying to disclose clumps of eggs. And as she goes along, more will come out. It's like a tube of toothpaste just getting rolled up, and each time more eggs come out. So at the very end, she'll just, um, just look like a legs and head and wings. So, um, but every time she encounters that water surface, she's of course going to be vulnerable to fish and have a chance of being eaten. The takeaway from that, though, is if you're fishing an egg-laying female, she doesn't just come and lay on the water to lay her eggs. She's down and up and down and up. So as you're fishing, keep moving your pattern around to imitate the actual true behavior of that female stonefly. Oh, here it is. Here's a freshly molted stonefly, and you can see just a bright white. I have a little arrow there. That was kind of the brown mottled color of the nymph itself, and that little piece of the cuticle had not quite fallen off. And so kind of fun, kind of interesting. If you're fly tired, tie up a white pattern and fish it this summer, and let me know how you do with it. Okay, finally, one last order of insects, and that's the caddis. This is the first group of insect that has a complete metamorphosis, so sort of analogous to butterflies and moths. And so with the immature stage in a complete metamorphosis, meaning a complete radical change, we call the immature stage a larva. So that's always fun to know. Why do we have larvae and why do we have nymphs? That's the whole reason why. So the female will lay her eggs into the water, and little kind of grubby maggot-like larvae will grow and hatch and develop over the course of a year. Caddis evolutionarily are certainly more advanced than some of the other, well, certainly more advanced than mayfly and stoneflies, but they're quite unique. And there are different groups of caddis. Some are a little more primitive in that they are free living and they just crawl around on a rock feeding and are very basic, just a little grub out there. Some caddis build very elaborate cases. They might be made out of sand grains or sticks or plant material and move around with them. Some build cases and don't move at all. We also have caddis that spin silken enclosures that might look like a little bag in the river. Some have little caves, like they'll build a little cave, and in one section, it's like a duplex. One side is for the larva and the other side is for food collecting, and the larva will live in the one side, and it will come out and check the web and see what's for breakfast, what's for dinner, and so on. And we have lots of caddis like that. So kind of a really fascinating group of insects. They will grow and change over the course of a year, and then they'll spin some kind of enclosure and go and pupate. So those that are case caddis oftentimes just close up the case and change in there and then emerge. Well, we don't have to talk about what every group does. I get kind of excited, sorry. But after 2.5 weeks or so, that pupa will be ready to emerge, and it will make its way out of the pupal chamber and then swim to the surface and then split along the thorax, and the adult will emerge from there. This emerging pupa is probably the most vulnerable stage of the insects' life cycle stages. They got to get from A to B to C to D, and so getting to the water surface, that's where they're most apt to encounter trout. And then the caddis itself, when they take off, they'll, you know, disappear to surrounding most of the vegetation along banks and so forth. A lot of times you'll be fishing, you'll put your hand up and you know, this cloud of caddis will come out of there. And when you stop and look more closely, you'll see they're all mating, um, and then the caddis will, the females again, will be the only ones to come back to the river. They may lay their eggs by dipping. Some of the caddis will actually dive down and lay their eggs on vegetation and so forth in the water. So lots of things to imitate in this particular life cycle. All of these different stages can be imitated with a fly. And again, some are going to be more successful than others, but quite often the pupa, the emerging pupa, sometimes that's called a ferrate adult, is probably the most vulnerable stage. So here's an example of a free living caddis. So certainly more attractive than a maggot. I hate to use that word, but it's a little grub with cute little legs. Many of these free living ones are rather bright colors. Case caddis, again, you can oftentimes identify these right down to the genus, just based on the type of materials that the case is made out of. If you look down in the lower right, you can see the little legs of the creature, but that's about all that you can is visible. Some of the cases are portable. Other cases, as I said, are fixed and just remain in place. Here's an example of several different cases. Some are, you know, look kind of like a hobo, and others are very perfectly made, perfectly like a little chimney. The caddis on the upper right, that's a case, that's one of the caddis that builds the little cave retreats. And I still need to get a nice photo of that. I need a waterproof camera to do that. I'm still working on that. But you can see in the lower right, you've got even little bits of shell and shells and rocks and sticks. So all kinds of materials that caddis use for cases. So here's a case, excuse me, here is a ferrate adult, or that emerging right before it's ready to emerge. And it reminds me a little bit of some of the packaging of today. If you go in and you buy a toy for a kid, I swear the plastic, you can see the toy in there and it takes you 20 minutes to get it out. And you look at this and you can see the caddis in there. You can see the eyes, the long antenna, you can see the wings are just perfectly jammed in that package. And you know, it's just got to get out. And so it's kind of like it's ziplocked into there, and it allows it to be nice and waterproofed and streamlined so it can swim to the surface and then allow the adult to safely emerge. A caddis adult, caddis are kind of some of the more drab looking adults. They have two pair of wings. So all of our insects that we looked at tonight had two pair of wings, and they hold their wings over their back in a tent-like fashion. Their wings are longer than their body, and they always have two long antennae. They don't have any tails as adults. It can be a little challenging to identify. And so a lot of times we, as anglers, we have some kind of generic forms that we tie that are different sizes and different body colors. And then of course, try to imitate them by making the fly behave like the natural. So these are all different caddis adults, so they're not all drab and brown and boring. When you get into trying to identify caddis, looking at the length of the antenna versus the length of the body can help you to identify them using a hatch guide. Sometimes you can just look at the wings, especially like in the top left and lower right. Those are very easily identified just by the, the fanciness of the wings. That caddis in the lower left, those antennae are so long that they're another probably 1/3 the length that's actually showing in that photo. So lots of different interesting things about this insect. Um, in imitating any of these stages, you can certainly tie a cased caddis. It's probably not going to be the most successful stage of the insect cycle to imitate, but it's fun to do. It's fun to try. It's fun to try to catch a fish with a cased caddis. It's funny is, caddis have evolved developing and building a case to try to avoid predation. And funny thing is, fish have figured this out, and sometimes they very much do eat case caddis. The pupa stage is what I think is probably the most important. Um, this particular one that I have an arrow on is tied by a friend that has since passed away, but that thing almost looks like it's an alive, that perfectly segmented body and long antenna and wings, looks exactly like the real thing. Different style caddis patterns. The one on the left is mostly an elk hair style. That's going to be a good pattern on rapid water where it's needs to be up and off the water. The pattern to the top right, more, that's called a ribbon. That one's actually called a ribbon caddis, but there's also a Henryville style pattern that sits very low in the film. And I think of rivers like the Missouri River out west, where you have to have a pattern that virtually sits right in the film. And sometimes even a pattern like that ribbon one is not going to sit flush enough, and you've got to go to a pattern that's all CDC or something to really fool a fish. I always have X caddis in all of my fly boxes. That antron that's used in the tail there, that's imitating the shuck of the ferrate emerger as it comes out, and the wing, the adult wing is coming up to the left, and the shuck is there to the right. Very, very successful pattern. So to summarize, in the end, you really need to stop relying on your fishing partner for all of his or her fly recommendations, and make your own decisions. And hopefully this will kind of inspire you to learn a little bit more and try to be a little more analytical on the river. And in the end, I hope you become not just better at fly fishing, but better at fly catching as a result of some of what you've learned tonight. So with that,
Wow.
let's see if there are any questions. I have one more slide. I'm gonna leave this up. Um, and again, this is gonna be coming out sometime this year. I can't tell you what month it is, but it will be out this year. So April, do you want me to stop screen sharing? And
No, you can leave that up, and we'll do some,
okay,
we'll take some
all right.
questions. Well, everyone's typing their questions, and you can do that, everyone, in the chat or in the Q&A section. I have a question about eggs, Anne, and I'd also like to say that was spectacular. Thank you.
Thank you.
How long do the eggs lay? How long do they stay down there before they start to hatch?
Well, that's a great question. So it depends on species. Some eggs will hatch right away and start to develop, and it all kind of depends on what the insect eats and when it's laid. So in some insects, they'll hatch right away. In others, they will rest for a while and then begin to develop after a few months. Um, in one mayfly that I'm thinking of, the gray drake. So I think that's across North America. Um, the eggs are laid and they don't really start to hatch until winter. So they spend all that time um, in a stage of rest. And in with insects, that's called a diapause. So it's hard. It just depends on each different species what they do. And some eggs, which I find very interesting, can actually go. They can actually be eaten and pass through a fish and be unchanged, um, which is kind of cool. They're not actually. They might pass through very quickly. Not all of them, but a lot of them. So everything is unique.
Yeah, right. Got it. Yeah, I'd heard there were some that it could take up to a year, but I didn't know if that was true. Wow.
A whole year to develop that, I'm not aware of that, but like the gray drake is the one that I think. So here in the Midwest, that they're laying their eggs in June, and so it might be into January before those hatch. So um, mhm.
Long time. Yeah, got it. All right, let's excuse me, turn to the Q&A. All right. Lots of thank yous, lots and lots of thank you. Yeah, Struan, didn't see your email. We'll type it in the chat again. Did you want to just say it out loud while I'm typing it in the chat?
Yeah, so it's just Ann R. Miller, like the signature on my book, no periods or anything, at goodold AOL.com.
I've just added it into the chat as well again.
Okay, great.
Okay, and then back to the Q&A. So lots of thank yous. Oh, William, William's asking if the recording can be found. So, and I had typed that you can find the recording in the members section. So yes, so Anchored Outdoors is a membership. And so we've got a ton of great content for members, but we archive all the presentations privately for members. So they're in the members section. So if you just go to anchoredoutdoors.com, you'll find all that stuff. Stan. Oh, hey, Stan, how's it going? Speaking of favorite members, is there any nutritional value to the discarded shuck? Great question.
That's a great question. So the answer to that is no. There is no nutritional value. However, some juvenile fish will try to feed on those, and juvenile wild fish very quickly learn to, they might eat them once or twice, but they quickly learn that, there's no value there. But they've learned that hatchery fish oftentimes will continue to feed on those for quite a long time. And so there again, we poor old hatchery fish, they get a bad rap, but apparently for good reason.
That's amazing. Chris, he says, if I do my research on a river and determine colors of insects, can I count on the colors being the same the next year, or do the colors change?
That's a great question. So again, it depends. In some different, so in that whole crawler stage, that's pretty much the ephemerellas. And some of those Latin names have changed, but a lot of those have different male and female, but the water chemistry can very much influence them. And if you go from river to river, you may find some subtle differences. I know for certainly with hexagenia, and I think everybody is, well, it depends on where you live, whether that's an important hatch. It's very important in the Midwest, and I know there's pockets of it out west, and certainly some in the east. If you see hexagenia, that can also live in a lake. And if you see hexagenia in a lake versus hexagenia in a river, you'll notice a big difference in color. And that's, again, it might be water chemistry. It's probably water chemistry. I don't want to speak out of turn here. I know that water temperature is important, and oftentimes influence the development of hexagenia. That in a river, in a cool water river, a hexagenia here in Michigan might take 2 years to develop. But if it's in a lake situation, it might take only a year. Um, but we have, different broods of them going all the time. So we see them every year regardless. So with stoneflies and other things, the color might not be um, as variable. Um, but in some of the groups of mayflies, definitely color can vary a little bit.
Mhm.
Hues, so um,
Yeah, and I think that's going to segue us into some of these outstanding questions. Dustin says, "How does this information change based on geographic location in terms of weather? He lives in central Alberta, which is very cold. Does this condense the period of time for these hatches to occur?"
yeah, good question. So temperature is really important, and um, we look at air temperature and you look at water temperature, and a lot of it has to do, so if I'm raising insects and suddenly the temperature, hits 64 degrees, everything in my tank didn't just suddenly hatch. It just doesn't work that way. There's something called degree days where a river, it's kind of a synergistic effect where you have to have so many days that the river is at this temperature, and so it influences the development of the nymphs. And so if it's super freezing cold, it can really slow development of the insects down, because all of those other, the degree days haven't brought the river up to temperature. And there have been studies where, they've taken, again, this hexagenia and, you know, completely shortened the life cycle just by warming the water over the course of a year, and completely changing and shortening the development time. So, to answer your question, yes, in Alberta, you're going to be more condensed. You're probably not seeing a lot of insects. Um, you've got to still have ice on the river there, probably. Um, geez, probably into March and even April. So things are going to happen in a lot shorter time span than say someplace like Michigan.
Got it. Charles asks, "Does a particular species lay its eggs at the same time of year throughout the country?"
Um, yes. So yes, to a degree. So if you go across the latitude, so again, let me pick hexagenia. So um, where I live, I'm in southern Michigan. I can I can hexagenia will start. I'm just going to pick a date to make it simple. June 1st. And as I travel north in Michigan, I can continue to fish that hex hatch probably for 3 weeks as I go north. Um, so I can't say June 1st all across the country I will have hexagenia hatching. It has to do again with that degree days thing, which will be influenced by geography, um, and degree days and temperature, if that makes sense.
I've got two questions here, one from Jeff and one from Arthur, that are both very similar. Jeff says, "Over time, have you seen species change from stream to stream due to changing environment?" And Arthur asks, "Is climate change having an impact more on all insects, or specifically on mayflies, stoneflies, or caddis?"
Well, I would say, so the answer, they are very similar. So definitely insect hatches are changing. Our rivers are changing. They're definitely warming up. Um, they're definitely influenced by, development, agriculture, runoff, warming temperatures. Um, and I'd have to say, experientially, I feel like hatches aren't necessarily as good as they once were. I hate to say that, but sometimes you feel like things have changed. Certainly, caddis have changed. So in the West, you still have a lot of tailwaters, and here in the Midwest, we have been decommissioning a lot of our dams. And so when I talked about caddis, there are a lot of caddis that, the kind that build a little net, or the little cave dwellers. They are very common in tailwaters because they're basically out there with a seine collecting food, as it drifts by. Which, when you have a tailwater, it's constantly fluctuating. The water level changes, things get stirred up, and caddis are very good at taking advantage of that kind of habitat. As we have decommissioned dams here, I'm just here in Michigan, for example, we've seen caddis, those tailwater type caddis, pretty much disappear. But also, they have been very much helped along by the introduction of zebra mussels. And so some of the invasive species that have come along have really changed populations. And I don't know if you, I don't, hopefully you don't have these out. Well, I know well, I don't know if you have them out west, but they came in through uh, big tanker vessels from Russia. And when they emptied their, um, ballast water out, we ended up with quagga mussels and zebra mussels, which, you know, just are great filtering creatures. And so you could put them in a big tub of cloudy water and they would just suck the daylights out of it. So we went from streams that had, millions of caddis to no caddis at all, and it turned it into a complete mayfly hatchery instead, because you had more sunlight coming into the river. And so now you've got algae and you've got diatoms growing, and now mayflies can come in and feed on the diatoms. And so over 20 years, 25 years, that those hatcheries have entirely changed.
Mm, gotcha. Struan asks, what sort of insects like reddish tan colored river waters?
Reddish tan river waters.
Mhm.
I'm not sure I understand.
Reddish tan. Oh, tannin probably. I would imagine.
Tannin.
Mhm. Like in New Brunswick and Norway, there's a lot of reddy tannin rivers.
Um, well, I guess I can't directly answer that. I need a little more information on that. The higher acidity things, that's going to make it more difficult for a lot of creatures to live there. And right off the top of my head, I can't come up with a good fauna that would be in there. I'd have to get in there and sample it a little bit.
Yeah,
I
you
don't
still,
have something to compare that to here. I'm thinking of, I can think of some habitat that has that, but I can't think of rivers that have that.
he's saying
That's
Algonquin.
going to be a hard, it's going to be a hard place to live, I guess.
Yeah, he says Algonquin. I don't know how familiar you are with that.
Yeah, I've been to Algonquin. Yeah, and I'd have to do some digging. I'm not coming up with anything real quick there.
Yeah, gotcha.
Sorry.
It's all right. And then Curtis and Dustin have similar questions as well on seining the river. So, Curtis, I'm happy you made it as well. When you seine in a river and don't come up with anything dominant, what is your go-to? And then to back end that, Dustin says, do you always recommend seining it before you fish? And how often would you do that in a day? So, what do you use if you don't find anything? Do you always recommend doing it? And how often do you do it?
Okay, well, if I don't find anything there, and it was a new river, I probably wouldn't fish there.
Oh, wow.
Yeah. I mean, because in seining, I can even find, if there's no insect material, there's not going to be any, probably little fish, and so there's probably not going to be any big fish. I can always, I mean, if I go later in the season, maybe that's a little harsh. If I go to a brand new river and I turn over rocks and I seine and I don't find anything, I probably, and I go to a number of habitats. So I go to gravel, I go to woody debris, and I go to plant life, and I don't find any insects, I'm probably not going to fish there.
Mm.
Second, I always have a seine and I'm always turning rocks over. So I'm probably, more unusual than the normal angler. But also, I mean, in fishing, the rivers that I go to, I know what to expect because of experience and because I've spent all this time researching them. So when I go to a new river, I do always seine and I do always, do a little research in advance to see what's there. Um, so, go-to flies, honestly, I guess the question there is a searching fly. Um, and there again, if I don't see any activity, um, eh, I'm going to be honest. I hate nymphing. I hate nymphing. I hate straight up nymphing, and I will go to a streamer instead. I will use a nymph during a hatch when I know what's happening, but to nymph as a searching pattern, I just don't enjoy it. Um, I'm a lot more visual, so I'm more apt to go to. Um, I'm using my brain all the time. So if I'm not seeing a lot of things and I know what time of year it is, I know what's supposed to be going on. Um, I kind of run through the motion, the gears. It's like, am I here at the wrong time of day? Why is nothing happening? And I tend to, um, you know, probably overthink sometimes, but I fish when I have time, but I'm also not going to go to the river at 1 o'clock in the afternoon in July because that's not going to be a good use of my time.
Gotcha.
I don't know if that was helpful or not,
Yeah, it
but
is. It is. I'm almost done. Steve would like to know a little bit more on the drift and how to fish it.
okay. So there's a case of where I would fish a nymph because there I know they are moving around. There are certain insects that drift more than other insects, and you can do a little research on that. Everything in the Batis family, the blue-winged olives, and there are lots of different species in there. They drift a lot. They're big time drifters. We didn't talk about midges, but chironomids drift a lot. Um, so it's a little tiny worm-like thing. Scuds, nymphino, excuse me, drift a lot. So, and some other mayflies, some of the ephemerellas also, a lot of caddis will drift. Not so much, well, some of the case caddis too. So again, it will depend on the river and where you are in the habitat, but uh, though some of those different things drift more than others. So for example, like I'll just pick Isonychia. That's a big swimming type mayfly nymph that, because they can swim already, they are not apt to drift. Um, Things like hexagenia, the burrowing mayflies, they don't drift. So how I would fish that, and I've done this right at dusk, less at dawn, because I'm typically fishing some of the evening hatches. And so at dusk, or right at that drift time, you'll be fishing. There'll be a lot of insect activity on the surface, and then suddenly everything stops, and that's when things are happening underwater, and that's when I'll put a nymph on and kind of high stick that through there and fish it like that.
Got it. That's helpful. Last question. William says, loving this. Thank you, Anne. How does the fish's diet change over time?
Oh, great question. So fish prey size is going to be important. Younger fish are up until fish get fairly old. The bigger fish, they're all going to be eating insects. And then as a fish gets older, they're also going to start eating smaller fish. So when younger fish are going to be eating a lot of, the three groups that we talked about, you can imagine as a young fish with some of those, like for example, really big stoneflies, that's probably a larger prey item than they can handle. And so they might not be able to eat that when they're, say, 1 year old. Um, Also, as fish get older, say like 3 years old, they will also start to um, feed on terrestrials. And terrestrials, a lot of times, are pretty good morsels when you think about grasshoppers and some beetle size, not so much ants, but some of the bigger insects. As fish get older, that becomes a really important part of their diet.
Got it. I personally have one last question. My daughter is really into this YouTube series called Deep Look. She loves bugs. And she's showing me this horrible video on hairworms.
Oh, yes.
They're just wretched things. And I just had a thought. So, for people who don't know, the hairworm is what, the larva or something in the water. The mayfly nymph eats it. Crickets apparently are meat eaters. I didn't know this. They eat the mayflies. The hairworm then hatches in the cricket, plays with its neurology, makes it go to the water, and then this horrible long worm that I've seen hatches from its abdomen, and it's quite traumatizing. If a fish eats a cricket, will that worm then feels the water in the fish or liquid in the fish, will hairworms hatch in fish?
I don't think so. And I don't know a lot about them, but I just read something about them, but I'm going to want to watch this video. Um, but with a lot of parasites, they're very specific, and some have more than one host. So it will depend on the particular hair worm, and they really are. I have seen pictures of them, and they really are very disgusting. So I can't fully answer that, but if I find out anything, I will get back with you on that.
Yeah, let me know. I think we've watched it probably 20 times now. She watches it on repeat. I think she's sick. Yeah, just YouTube Deep Look hairworm. And Tom Brown brought it to my attention because he said, when you're out in the bush and you're starving, don't eat certain bugs because they carry parasites. And then, of course, yeah, it's all just timely. But all right, yeah, if you hear anything, please do let me.
I will look that up. Yeah, because I've been doing some research on the terrestrial section, and that is when I was started, reading about grasshoppers and crickets. That's when the hairworm thing came up, and it was like, ew. But I don't think it's passed on to the fish, but I will look that up. I'll find out.
Thank you very much. Well, Anne, I cannot thank you enough for making the time to do this. Tons and tons of chats and questions, or not questions, but people commenting saying, thank you so much. Very awesome presentation. They just keep rolling in. So on behalf of all of us, thank you so much. And I cannot wait to see your new book. Keep us posted. And we know how to reach you, and just, you're killing it. Thank you so much.
Oh, thank you, April.
Okay.
Thank you. Good night, everyone. Thanks for joining.
Thanks. Have a wonderful night.
Okay, you too.
Okay. Bye.
Bye-bye.